In this video, we're going to go over how to graph lines. And the easiest way to graph lines is what we call in slope-intercept form. Slope-intercept form is y equals mx plus b. M tells you your slope, while b is your y-intercept, which is in the form of 0, b. So why do they call this slope-intercept form? Because it tells you the slope, that's your m, and it tells you your intercept or your y-intercept, which is your b. So the name tells you exactly what they are telling you in this form. We also have something called a linear function. A linear function, instead of y equals, is f of x equals, but then everything else is the same. So f of x equals mx plus b. So again, m tells you your slope, and b is your y-intercept in the form of 0, b. So what this really tells us is that y and f of x are equal to each other. So we can interchange them as we want to or as we need to. So slope-intercept form of an equation of a line just says y equals. Your linear function has function notation, but they are treated the exact same. So in this example, we need to determine the slope of the y-intercept of the linear function g of x equals negative 3x plus 1, and then we are going to graph it. So what is my slope? Well, my slope is whatever's in front of that x. So in this case, this negative 3. So here my slope is negative 3. Now, I know from the previous lesson that when I am graphing, I need rise over run. So I need to write negative 3 as a fraction. And we can either write negative 3 over a positive 1 or 3 over a negative 1. And I'll show you how we can use both of those. What it does not equal is negative 3 over negative 1, because negative over negative is positive. Okay, so you got to pick that negative to either go in the numerator or the denominator. It cannot go in both because that's positive. And then your y-intercept is whatever doesn't have the x, in this case, this 1. It doesn't say how to write this, but I'm going to go ahead and put this as an ordered pair. So this is 0, 1. When you graph, you are always going to start right here with the y-intercept. So I'm going to plot my y-intercept of 0, 1. And then use your slope. So if I use this first one of negative 3 over 1, my rise is negative, so I'm going to go down, but then my run is positive, so I'm going to go positive to the right. So from this point, I'm going to go down 1, 2, 3, run 1. Go down 1, 2, 3, run 1. Go down 1, 2, 3, run 1. And then I don't have 3 more places to go down. We could have used this slope instead, which means my rise is positive, so I'm going to go up 3, but my run is negative, so I'm going to go to the left 1. So from this point, I'm going to go up 1, 2, 3, run a negative 1. Go up 1, 2, 3, run a negative 1. And I have room to do that one more time to go up 1, 2, 3, run 1. Now to graph this, you only really need 2 points, but it does come in handy to do this whole thing when we go to our next lesson. Okay. And then we can kind of check. It says that my slope is a -3, and this is a decreasing slope. Now B wants me to find the slope and the y-intercept of the line 2x minus 5y equals 10, and then graph. The problem with the way that they gave me this equation is this is in standard form, and I need this into slope-intercept form, which means we need to solve this for y. So to get y by itself, I need to move this entire term over. So I'm going to subtract 2x from both sides. I am left with -5y equals. These are not like terms, so we cannot combine them. It would be fine if you did 10 minus 2x, but because I know I want that x first, I'm going to write this as -2x plus 10. Okay, y is still not solved for. Now I'm going to divide by -5 to get rid of that. Be careful here. What am I dividing this side by -5? The -2x or the 10? That's a trick question. Hopefully you said both. I am dividing everything by -5. So now I have y equals -2 over -5. The only thing I can do there is take the negative away. Negative divided by negative is positive. So this is 2 over 5x. And then 10 divided by -5 is -2. So now this is in the correct form. And so now I can say that my slope equals 2 over 5. And I can say that my y-intercept is 0, -2. When we graph, we are going to start right there with that y-intercept. So I'm going down here to -2. And this is my rise over run. So it's +2, which means I go up 2 and then run a +5. 1, 2, 3, 4, 5. I'm going to do that again. So up 1, 2, run 1, 2, 3, 4, 5. How could I go in the opposite direction? Well, 2 over 5 is the same as what? -2 over -5. So it means I can go down 2 and run a -5. So I could go from this point down 1, 2, run 1, 2, 3, 4, 5. Down 1, 2, run 1, 2, 3, 4, 5. And then the last question on this is the slope increasing, decreasing, or constant? And this one has a positive slope, or it is going up from left to right. So this one is increasing. Okay, last part of this video is we're going to actually do a little bit of an application problem. It says the annual fixed cost of owning a small sedan is $4,252, assuming the car is completely paid for. The cost to, let's drive it and not dive it. The cost to drive the car is approximately 14 cents per mile. Write a linear equation that relates to the cost C and the number X of miles driven annually. What is the cost of driving 4,000 annual miles a given year? So we're going to be putting this in kind of our y equals mx plus b form. And I'm going to go ahead and actually put this as f of x equals mx plus b form. Okay, but they're saying that the cost is going to be c, so instead of f of x, this is now my c of x. And then it equals my mx plus b. Okay. Well, we have two numbers that they gave us. We have 4,252 miles. So I'm guessing these annual costs are like your tire rotations, your oil change, getting new windshield wipers. Okay, that's how much it's going to cost us a year. And then we're going to go it costs us about 14 cents per mile. Which one of these is constant and which one of these is going to change depending on what we do? Well, this one's going to change because this one's 14 cents per mile, while this one here is just a fixed cost. So this is going to be 0.14x plus my fixed cost of 42.52. So in this first part, write a linear equation that relates to the cost and the number of x and the number of x of miles. This is my linear equation. So then the next part, what is the cost of driving 4,000 miles? We're going to take the equation we just made, and now I want to know what happens when x is 4,000. Okay, so we'll use our calculator. We have 0.14 times 4,000 plus 42.52. Word problems need word answers. So the cost, I don't have room to write it, but the cost of driving 4,000 miles an annual year is $4,812 or something like that.